Welcome back to SRBPS online classes, and today we are going to discuss chapter 2 of 8th class maths, that is power or exponent. And today we are going to discuss about the laws of exponent. Some of the laws we had discussed in our previous classes, and today we will discuss the rest of the laws, that is negative exponent rule, fractional exponent rule, zero exponent rule. So let's begin with the negative exponent rule. What is negative exponent rule? We will apply negative exponent rule when the power is in the form of negative. When the power is negative, then we will apply negative exponent rule. See here, if we are having a raised to the power minus n, if we are having a raised to the power minus n, then that is equal to 1 upon a raised to the power n. Okay, now see the example. Here 5 raised to the power minus 2 is there. 5 is the base and power is in negative. So we will use negative exponent rule. Then 5 raised to the power minus 2 will be equal to 1 upon 5 raised to the power 2. And this is equal to 1 upon 5 into 5, as the power is 2. So we have to multiply 5 2 times. And this is equal to 1 upon 25. So this one is the answer. Second one is the fractional exponent rule. Fractional exponent rule is also known as rational exponent rule, because here the power, it is in the form of m by n. Let's see what is it. A raised to the power 1 upon n, a raised to the power 1 upon n is equal to nth root of a. A raised to the power 1 upon n is equal to nth root of a. A is the base. Now what does n here? Suppose if the value of n is 2, if the value of n is 2, so it will become the square root. And if we have the value of n is equal to 3, then here we will have the cube root. Okay. Now we can write down the fractional exponent rule in this form also. Here we are having a raised to the power m upon n. A raised to the power m upon n. So here m represents the power of the base and n is the nth root. N represents the root. If here we have n, that will represent the nth root. If here again square is there, so it will represent the square root. If we are having the value of n is equal to 3, then it will represent the cube root. So a raised to the power m upon n is equal to a raised to the power m, its nth root. Nth root of a raised to the power m. Let's see the example. 25 raised to the power 1 by 2. This form we are discussing. So here the value of n is 2. So this is equal to square root of 25. And what is the value of square root of 25? That is 5 only. So this one is the answer. So at last we are going to discuss about zero exponent rule. As the word sound, when we have to use the zero exponent rule, when power of any number is 0. When we have the power of any number 0, then we have to use zero exponent rule. And in this rule, if a is the number whose power is 0, then its value is equal to 1, where a can be any non-zero positive numbers. See the example, 300 raised to the power 0, that is also equal to 1. 1 raised to the power 0, that is also equal to 1. So, in zero exponent rule, whatever number we are having in the base, if its power is 0, then its value is always equal to 1. That's it about the laws of exponents. Next we are going to discuss about the scientific notation, how we have to write down the numbers in scientific notation form. That we are going to discuss is scientific notation. So what is the form in which we have to write down the numbers in scientific notation? That is C into 10 raised to the power n, where C is the number which is greater than equal to 1 but less than 10. It means our value of C will lie between 1 and 10. It may be equal to 1 but not greater than 10. So, and here n is the integers. Integers means we have the power in positive or negative or 0. So, can you tell me what is the use of scientific notation? Why we are using to write down the numbers in scientific notation form? Because with the help of scientific notation, we can write down the large number as well as the smaller number very easily. Let's see with the help of example. See here the first example. This one is the large number. This one is the large number. So how we will write it? As 84912 means we have 0 here. So we have to shift this point here. Okay. So in order to shift it here, what we have to do? We can write it as 8.4912 into 10 raised to the power. How many digits we have crossed? 1, 2, 3, 4. So here 10 raised to the power 4 will come. Now this one is the smallest number, smaller number. So in order to write down the smaller number, we have to move this point here to the right side of the point, decimal point. This is the decimal point and we have to move to the right side of the decimal point. So its value will be 2.65 into 10 to the power. How many digits we have crossed? 1, 2, 3, 4. So here minus 4 will come. So now let us see how we will convert the decimal number into the scientific notation. What we are going to learn? How to convert decimal number into the scientific notation. So let's see. For converting the decimal into the scientific notation, we have to move decimal point. What we have to do? We have to move the decimal points either towards the right or either towards the left. Now, this is the number. It means here is the decimal. We can write this number as this also, because after decimal there is no use of 0. Means this one is the number and there is no change in the number if we will put the decimal here. Now, as we know that we have to move this decimal point here, so that before decimal point 1 digit should be there. Okay. And in scientific notation, always before decimal point we have to write down only 1 digit. So in order to maintain this form, we have to move decimal point here. Okay. So we are moving the decimal point towards the left side. This one is the left side of the decimal point. So the power will be positive. And this is equal to 5 to 5 point. And this is equal to 5.25. 2314 into 10 raised to the power, how many digits we have crossed? 1, 2, 3, 4. So here 10 raised to the power 4 will come. Now see the second example. Here this is the decimal point, and before decimal point only one digit is there. So this is in the scientific notation form. So we will write this as 3.2 into 10 raised to the power 0, because we don't have to, there is no need to move the decimal point. Okay, because here before decimal point only one digit is there, therefore there is no need to move the decimal point. So we will write this in this form. See the third example. Here is the decimal point. Okay, in order to move the decimal point here, because the condition is what? C is greater than 1, and here if we will take the point, decimal point here, then the value is less than 1. So we have to make it greater than 1. So for this we have to move this decimal point here. Okay, this is the decimal point and we are moving towards the right side of the decimal point. When we will move towards the right side of the decimal point, then in power we have to put a negative sign. So let's see how we have to write this. This one is 4.28 into 10 raised to the power. How many places we have, how many digits we have crossed? 1, 2, 3, 4. So here minus 4 will come. Now last one. This is the number. So here will be the decimal point. So we have to move this decimal point here. We have to move this decimal point here. So how many digits we have crossed? We have to cross. Decimal point is here and we are moving towards the left side of the decimal point. So the power will be positive. How many digits we have crossed? 1, 2, 3, 4, 5, 6, 7, 8. So we will write this as 6.02. There is no need to write down 0 into 10 raised to the power 8. Why raised to the power 8 is there? Because we have crossed 8 digits to shift the decimal point. 1, 2, 3, 4, 5, 6, 7, 8. That is all about the rule of converting decimal into scientific notation. This is the last topic that we have to discuss. So how in converting the scientific notation into the decimal, we have to remove this 10 raised to the power. Whatever it is, we have to remove this thing. After removing these things, that is converted into the number will be converted into the decimal form. You can see here, this one is the example of decimal form, and this we had written in scientific notation. So we have to write down the number in this form. Okay, so let's get started. See here, decimal point is here. So in order to remove it, we have to move towards the right side. When we are moving towards the right side, how many decimals we are moving? 1, 2, 3. 3 numbers we are crossing. So this 10 raised to the power 3 will cancel out and our number will be 3128. Okay. Now see the second example. 6.4 into 10 raised to the power 4 is there. So in order to remove 10 raised to the power 4, what we have to do? Here positive sign is there, so we have to use 0, 0, 0 in order to get 4 digit. Okay, so its answer will be 6, 4, 1, 2, 3. We have to shift. Here is the decimal. We have to shift here in order to convert in decimal. So how many? 1, 2, 3, 4 digit we have to cross. So we have to write 0, 0, 0 here. So this one is the decimal form. Now third example, 10 raised to the power minus 1 is there. If minus 1 is there, then we have to write down the smaller number, smaller than 1. So if the number is smaller than 1, then we have to shift this point before 3. We have to shift this point before 3. And here minus 1 is there. So we will shift only one digit. So here we are having 0.39. Now last one. Here 10 to the power minus 5 is there. So we have to shift this point before 6. And in order to remove 5, how many digits we need? We need 5 digits. So this will be 6, 1, 2, 1, 2, 3, 4. Now count 1, 2, 3, 4, 5. So here we have to write down the decimal. As minus sign is there, it means the number will be smaller than 1. Okay. So this is all about the scientific notation. Thank you.